Alright kids, today what we're going to learn how to assign oxidation number based on electron configuration. Now a few things to remind you from before. We've learned about oxidation number. What is the oxidation number? To kind of remind you from before, if you remember, oxidation number was number of electron lost, gained, or shared when an atom forms a compound. So how many electrons are shared, gained, or lost when an atom forms a compound? That was oxidation number, or some people call it oxidation state. And now the other piece of information I want you to remember from before was that if the oxidation number, again, same thing as oxidation state, different name for it, oxidation number is same as charges for ionic compound. So the ionic charges is the same thing as oxidation number for ionic compound. Also remember that. So let's go back to this oxidation number. Now we studied this from the beginning, but you were memorizing things without knowing why they were the way they were. For example, Pb, lead. What you would memorize at the beginning of this class was that Pb could be +2 or Pb could be +4. Did you ever ask yourself why not Pb +5? So we just told you that Pb +2 and Pb +4 exist, and you memorized it. But you're probably going to ask yourself now, it's like, okay, how come Pb +5 doesn't exist? How come Pb +6 doesn't exist? Well, it's a good thing you're wondering about that, because that's what we are going to learn today. We're going to make sense of these oxidation number. And remember, oxidation number is the same as charges for ionic compound. I'm actually going to give you guys the rules, and then we're going to do practice problem to make sure you get this down. Rule number 1, you remove or you add electron from the highest n. And think about this. Remember how we said like we have the nucleus and we have the energy levels going around it? And this makes sense. The farther the electrons are from the nucleus, they don't feel the plus charge anymore as much. So it's easier to remove or to add electrons. The other way I usually explain it is that, think about this. Nucleus is the mom, electrons are the kids. When you're near your mom, you can't do bad things. When you're far away from your mom, oh yeah, you can do a lot of bad things. The same idea. So it's easy to remove or add electrons when they're far away from the nucleus. Because when you're far away from the nucleus, you're not feeling that plus charge anymore because you're far away. So it's easier to add or to remove electrons. So we remove or add electron from the highest end. Because remember N1, 2, 3, 4, and it keeps going on. Alright, so that's my rule number 1. Now, rule number 2. Rule number 2. If same n, so if you're on the same energy level, if same n, then what you're going to do, you are going to remove or add electrons from the highest L. From the highest L. And keep in mind, we talked about this before. What do I mean by L? SPDF, right? L is the shape, are the orbitals. And if you remember, S has a lower energy than P. P has a lower energy than D. D has a lower energy than F. So it's on the same energy level, you remove or you add from the highest L. F being the highest L, and then D, and then P, and then the S. Now the last rule. Oops, sorry about that. Still trying to learn this system. Okay, last one. metals, they only have plus oxidation number. Metals, they only have plus oxidation number. But non-metals, they could have plus oxidation number and minus oxidation number. So metals only have plus oxidation number. Non-metals could be plus and it could be minus. They could have both. And now I do want you to kind of remind you what are these plus and minus oxidation number is. If you have a plus, what does that mean? That means you gained electron, right? Plus means what? Means you gain electron. What does minus means? Sorry, plus means you lost electrons. Oh boy, what did I just do? Okay, I was just testing you guys. So plus means you lost electron. And minus means you gained electron. Sorry for confusing you guys. I was just testing you guys. So remember that when you have a plus charge, a plus oxidation, that means you lost electron. When you have a minus charge, minus oxidation, means you gain electron. Don't forget the basic, like I just did. So these are the rules. I want you to remember these rules and look at these rules as we do practice problem. So let's go back to our PB. What I want you guys to do right now, pause this video and write down the electron configuration for PB. It's also a good practice problem. The last noble gas is xenon. And then after that is 6s2, 4f14, 5d10, and 6p2. I'm not going to go over how I find this because go back to the electron configuration slides lecture to see how we do electron configuration. So here's the abbreviated electron configuration. Once again, I like to do the 4f14 before 5d10 since we end with D before we go to P. This is the abbreviated electron configuration. Rule number 1, you remove or you add electron from the highest end. What is my highest end? Which one has a higher energy level? 6 is my highest end. But I have two highest end. Look at rule number 2. If the same end, you remove or you add from the highest L. Now, which one is higher here? P has a higher energy or S has a higher energy? This over here. Remember, P has a higher energy than S. So they both have the same N value. So the P is going to have a higher energy than the S. So this is the first electrons we are going to lose is 2. The first one we are going to lose is 2. So I'm going to become plus 2. Now pay very close attention to this. So here, the first one is going to be plus 2. I'm going to lose 2 electrons. And I'm going to cross it out like that. But here's the thing. I'm still on the 6th level, right? So now I can also lose these 2 over here. I can also lose the 2 over here because we are on the same level, right? You're on the same level. If you're on the same level, you lose from the highest L. My highest L is P. I lost that, so plus 2. But now I'm on the same level. I can also lose from the S. I can also lose these 2. But here's the thing. Before I lose these 2, I have to lose this one. Before I lose this one, I have to lose this one. So I'm going to add them together. So the next number would be plus 4. I usually use this example, which no one understands, but maybe whoever is watching this video will. It's like a pancake example. If I have, and bear with me, if I have a bunch of pancakes stacked up together, okay, before I can get to this pancake over here, I have to eat up the other pancake. So before I can eat this pancake, I have to eat this one, eat this one, eat this one, and then I can eat that one. So I'm going to add them all together. Hopefully that example made sense. So let's come back here. It's the same idea. Before I can get to these two electrons, I have to lose those one, so they're additive. So the next oxidation number would be +4. And this is why Pb plus 2 and Pb plus 4 exist and Pb plus 5 doesn't exist. Okay, ready to do the next one? Let's do our next one. Br. Let's do abbreviated electron configuration for Br. It would be argon and then 4s2, 3d10, and 4p5. Let's go back to the rules. Don't forget these rules. These rules are great. Don't forget the rules. Rule number 1, remove or add from the highest n. Which one is my highest n? My highest n is 4. That's my highest n. These two are my highest n. They're on the same level. Okay, now if you have the same n, you have to go with the highest L. Which one has higher energy, P or S? It's going to be P. So what's the first one I can remove? Is these 5 over here. So these are the first one I can remove. So the first oxidation number is +5. But I'm still on the same energy level, right? So after I lose those 5, I can also lose these 2. But before I can lose these 2, I have to lose these 5. So altogether would be +7. Think of the pancake example. So +5 plus 7 is the oxidation number for Br. Except Br is a non-metal. We said non-metal have plus and minus oxidation number. Now how does the minus oxidation number goes? Now what I want you to do, I want you to look at a periodic table. Let's see if I can select. If you look at this periodic table, okay, we're going to look at the Br. Br is right here, that's bromine. Oops, sorry for that. Br is right here, bromine. Now, bromine needs how many electrons to look like a noble gas? And remember, it's considered very sexy to look like noble gas in chemistry. How many more electrons does it need to look like a noble gas? It only needs 1 more. And that's why non-metals have also minus oxidation number, because minus means you gain electron. If they only gain a couple, 1 or 2 or 3, they're going to look like a noble gas. So it's worth it to do that, because minus means you gain electron and they only need a few to look like a noble gas. Br needs only 1 electron to look like a noble gas, and noble gases are considered sexy. They want to look like a noble gas. So -1 is the other oxidation number. So it would be +5, +7, and -1. Those are the oxidation number. So here's the oxidation number based on electron configuration. Now let's do a few more practice problem. So the next one that we are going to do phosphorus. Again, write down the abbreviated electron configuration, which is neon 3s2, 3p3. Okay, go based on the rule. The first thing I have to do, the highest n. My highest n is 3. These are the same energy level, right? If I have the same number of if I have the same n, then I have to go with the highest number of L. I have P, I have S. Which one has a higher energy? P has a higher energy. So the first one that I can lose is this one from 3p3. So my first oxidation number would be +3. Now the next oxidation number, I'm on the same energy level, right? I'm on the same energy level. After I lose this, then I can lose this one. But before I lose the 2, I have to lose the 3. So they're additive. So the next one would be plus 5. Okay, I will be done if phosphorus was a metal, except phosphorus is a non-metal. And we said non-metals also have negative oxidation number, right? Because if they gain a couple, they might look like a noble gas. Let's go to this page that I had a periodic table. If you look over here, and if you look at the phosphorus is right here. How many does it need to look like a noble gas? If it gains 1, 2, 3, it's going to look like a noble gas. Is number 15, 18 would be argon, would be very attractive. So if it just gains 3 electrons, it will look like a noble gas. So the other oxidation number is minus 3. Okay, now let's do a couple more and then we're good. The next one we're gonna do TB. Alright, we can pause my video and then do the oxidation number based on electron configuration, and then you can compare it to my answer. So xenon 6s2 5d1 4f8. Again, we've done electron configuration before. Hopefully you got that down. Now my highest N is 6. My highest N is 6. So the first one that I lose are these 2 over here. Those are the first one I lose. So the first oxidation number is plus 2 because I lose from the highest N. Because the farther you are from the nucleus, you don't feel the plus charge anymore. If you don't feel the plus charge anymore, it's easier to lose or gain. Okay, what is my next highest one? My next highest one is 5. But before I can lose this 1, I have to lose the 2 first. Think of the pancake example. So I would have to eat up those 2 and then eat this one. So my next one would be plus 3. Okay. Now, the question is, how many oxidation number can you come up with? And here's the rule. Do not go higher than plus 7. Because noble gases are considered the best, right? Those are plus 8. So don't go higher than plus 7. You stop after that. Because the next one, if I add it together, it would be 8 plus 1 plus 2. That would be too high. Now, next one is IN. Let's do IN. Again, pause my video and then do it on your own. The abbreviated electron configuration is KR. And then 5s2, 4d10, and 5p1. What is my highest N? My highest N is, my highest N is 5. But I have 2 on the same energy level. S or P, which one is higher? Hopefully you're shouting the answer that P is higher. So the first one I'm going to lose is this guy right here. My first oxidation number is plus 1. Now, I'm still on the same level, so I can also lose the 2 over here, but before I lose the 2, I have to lose the 1 first. So 1 plus 2 would be plus 3. Now, can I go to the next level? Not really, because 1 plus 2 plus 10 would be 13. That's too high. You can't do that. And IN, also TB, were only metals. So metals only have a plus oxidation number, versus non-metal have a plus minus oxidation number. And these 2 are metals, so only plus oxidation number, because metals want to lose. Non-metal could lose and gain. Now, last problem, and definitely pause this video for this. I want you to do it on your own. Oxidation number for sulfur based on electron configuration. Okay? Hopefully now you unpause me. The same thing. You're going to write down abbreviated electron configuration, which is neon 3s2 3p4. You have to go with the highest N. They both are 3. If they are the same N, then you have to go with the highest L. P or S, which one is higher? P is higher. So the first one that I lose is is a 4. That's the first one I lose. So that would be plus 4. I'm in the same energy level, right? So probably I can lose this one after that. I have to lose this one before I can lose that. So they're additive. If you add it together, the next one would be plus 6. And again, don't go past 7. Don't go past 7. All right, now here's the thing though. What is S? S is a non-metal. And again, I'm going to repeat this one more time. Non-metal, they have plus and minus oxidation number. Versus if you have a metal, has only plus. Metal just wants to lose. All right, so sulfur. Let's go to sulfur. Sulfur is right here for me. Here is sulfur. Where's my sulfur? How many does it need to gain to look like a noble gas? It needs to gain 2 to look like a noble gas. So my last oxidation number would be minus 2. Plus 4, plus 6, minus 2 are the oxidation number based on the periodic electron configuration for sulfur. Again, these things you memorized before, but now you can understand why they exist. Okay, nice job. Very nice job.